supermassive. It was millions of miles wide. Astronomers around the world admitted the evidence was impressive.
I have to say, when I first saw Andrea's video, I was stunned when I saw that star come out of the left side of the frame and go zipping around and go shooting off into the other end of the frame, and it moved around a point in space, and nothing was there.
That we could, with our instruments, effectively travel to the center of the galaxy, 26,000 light years away, and collect the evidence for such an incredible object was really an amazing achievement.
It seemed undeniable. A giant black hole, and at the center of our Milky Way. But how could such a monstrosity come to be? One idea is that black holes are born out of the death throes of enormous stars. Like a red supergiant, a star 10 times more massive than our own sun. Deep inside, temperatures soar above 1 billion degrees. Helium and carbon fuse into heavier elements: oxygen, silicon, sulfur. Eventually, the nuclear reaction creates iron, and the core stops burning. Then, the star implodes under its own immense gravity and goes supernova. What's left is a heavy core of subatomic particles, a neutron star, only about 10 miles across, but of incredible density.
In fact, it's so dense that a teaspoonful of neutron star matter would weigh about 1 billion tons.
If the neutron star is heavy enough, 3 times more massive than our sun or more, the implosion will continue.
Eventually, the gravitational pressure will be so large that the neutrons themselves will be crushed, and there'll be nothing left to stop the collapse.
The result is a black hole. Many researchers believe that the Milky Way is littered with small black holes, the dark, dense remains of dead stars.
There must be millions and millions of black holes zipping around our galaxy as we speak. But we don't see them in general because they're dead. They're corpses, and there's nothing there to light them up.
They might be invisible, but to a visitor, these small black holes, maybe 10 miles in diameter, would be especially deadly.
One of the scenarios that always gets me thinking is death by black hole.
Approaching a black hole, the gravity is so strong and space is so warped, it distorts the light all around it. If it's a small black hole, then soon you'll be distorted too, by tremendous tidal forces of gravity.
The tidal force is the difference between the gravity at your head and your feet. The gravity at your feet, if they're closer to the black hole, is a little bit stronger than the gravity at your head, and you feel that as something that is tearing you apart.
Stretching you from head to toe. The tidal forces unrelentingly getting stronger as they exceed the molecular forces that bind your flesh, as you snap into 2 pieces, and those 2 pieces snap into another 2 pieces.
And ultimately, you will pull your atoms apart. You will be, as we say, spaghettified.
And so you end up moving through space-time like toothpaste through a tube. And if I were to pick a way to go, that's how I'd want to go. It's got to be better than just getting buried. I mean, come on now.
A supermassive black hole, 1 million times wider, might at first seem more inviting. Since it has a larger event horizon, the pull of gravity is more spread out.
If you go to a supermassive black hole, the tidal forces are weak enough that you can fall not only through the event horizon, but deep down into the interior of the black hole.
So, with a good spaceship, you might be able to cross the event horizon into the black hole itself. Now, thanks to a computer simulation based on Einstein's own equations, we can see exactly what such a trip would look like. The supermassive black hole is surrounded by swirling light beams as superheated gas rushes into orbit at high speed. Light and matter are suspended by centrifugal force and then inevitably fall victim to the relentless pull of gravity. At last you cross the event horizon, the point where nothing can escape.
So let's imagine that we fall through the event horizon. That's the place where space is moving faster than light. We fall deeper down inside the black hole.
But don't expect the black hole to be black. Deep within, there's an inner horizon, a logjam of trapped light and energy.
At a certain moment, as we hit the inner horizon, there's this infinitely bright, blinding flash. That's all the stuff that's been waiting there, trying to get out, is just held there at the inner horizon.
Unfortunately, you wouldn't have long to enjoy the view.
It would vaporize you, roast you, vaporize you, marmalize you. Almost certainly, if you fell into a real black hole, you would simply, unfortunately, die.
Science fiction displays a bit more optimism, like the 1979 movie, The Black Hole. Space travelers do indeed fear this massive object.
I will travel where no man has dared to go.
Into the black hole?
Why, that's crazy.
Cuckoo is a Swiss clock.
But even more cuckoo, the heroes actually survive their descent into the beast, where they're treated to a heavenly experience. Popular culture has cast black holes as the freaks of the universe. And the supermassive black hole at the center of our Milky Way, weighing in at 3 million times the mass of the Sun, seems especially monstrous. But is it unique? To find out, astronomers are probing distant galaxies to see if our giant black hole is one of a kind, or nothing special. The Sloan Digital Sky Survey is taking a census of the big galaxies within 1 billion light years. For every patch of sky, a steel plate is created. Each hole represents an entire galaxy within our view. Fiber optic sensors are plugged in. Each measures the distinctive spectrum of light emanating from a galaxy's core and can detect signs of hot gas swirling into a black hole. You can see the results. Circled in red, virtually every major galaxy bears the signature of a supermassive black hole.
That was pretty amazing. Before that, we thought, yeah, maybe a large number of galaxies have black holes in them, but every galaxy has a black hole? That was something very interesting.
The closer we look to the centers of galaxies, the more we find these black holes, and the inventory is rising high. So any idea for the formation of a galaxy will now have to include some explanation for how you get a black hole in its center.
So how did every big galaxy in the universe end up with a giant black hole in the middle? To understand, we have to go back to the very beginning. The Big Bang.
You got the Big Bang handing you your birth ingredients, your hydrogen, your helium, your traces of some other elements. So it's kind of like this soup. You put it together and stir it.
The main stirrer for the soup is gravity, drawing together wisps of hot primordial gases. Over time, the clouds of hydrogen gas cool down